don't need some of those rules that we used to need because you guys, like, our community is established, right? I think you guys have enough respect for each other to at least be like, hey, this is the easy way to do it, but not walk up to somebody and be like, oh, well, that's easy. Psh. Like, like disrespecting them. Slope. The reminder that we need. Guys, a lot of us try to do this upside down. It's y over x. This messes with people because normally it's x then y because it's like alphabetical order. It's not for slope. For slope, it's y over x. So here it'd be 4 over 6. Or that could reduce to 2. Ooh, careful. 2 over 3. So here our slope for rider A is 2/3. What would our label? Well, that should have a label. Labels are important. What was your Y label? What was your X label? So that's the label we're going to have is kilometers per minute. So 2/3 kilometers per minute. Or guys, the other way to say that is 2 kilometers every 3 minutes. Right? 2 kilometers every 3 minutes. Now, can we find the slopes for B, C, and D?
I don't know.
We don't have what? The numbers. We don't have the numbers because we don't have the... Guys, I didn't think about this till last class. You don't know what I'm asking for right now, probably because you've never took time to think about this. This is a lattice.
Nope, that's hurting my head.
A lattice is perpendicular, either all diagonal or like up, down, left, right, and it's often used to like keep animals out from under your patio. So like you might install decorative lattices but guys, these are called lattices, and that is what leads us to having lattice points. Lattice points are what allow us to find the actual numerical slope, right? Because we need to know exactly where those points are. So we can't just take random points. We need nice lattice points. But the problem is your graph is missing the lattice. So, yeah, unfortunately, I did this on purpose this time. You and your partner, now that you can see these points, label those points and see if you can figure out all those different slope triangles. Use my graph up front. Guys, I had to like super darken. I had to like make the copier go as dark as it could to get the lattice this dark. Using those points, figure out your slopes now. Or you can at least count the lattices, right? Like now that the triangles are on the lattice. So these are using lattice points because they're nice. They're whole numbers, right? They're whole numbers. They hit on the crosshairs. They're nice.
I wasn't sure when I tried it first. Didn't you still do it without it?
You don't have to have the lattice if you can figure out where the points are, but do we trust that all those points are nice? Like that's what we don't know. But now that we look up here, we can see like, okay, nice point, nice point, nice point, nice. These are all nice points.
Great. You should all get a present from Santa.
So like if we start kind of using our lattice points to set up that slope triangle, what about, the next line down, this next triangle here for person C, excuse me, what's the vertical or the delta Y?
2.
What's the horizontal?
3.
So guys, go ahead and label, that's a 2, 3 on that next triangle. Meaning our slope for C is, wait a minute. Isn't that the same as what our slope was for A?
Because it is.
Wait a minute.
Rider A and rider C are no, wait a minute.
No.
Wait.
They're
They started
well,
it different.
hey, I didn't even finish my sentence. What's up?
Can I borrow the shape stencils?
Yeah, up here. Blue thing. Although I think you left it somewhere if you just said again because Miss Howard brought me one back.
Oh, yeah, she brought them back. We forgot because it was the first day of track.
Very bottom. There you go. So, wait. So they have the same slope, But what's different about them? Maya, do you know can you spot what's different about A versus C?
The A, they start at 7 kilometers instead of 0.
Guys, if this is a race,
That's not fair. It's not fair.
isn't that a little sus? Isn't that come on? A
But B still wins.
A started 7 kilometers into the race. This is like they woke up at their apartment 7 miles into. They're like, I'm just gonna start here. Who cares about that? I'm just gonna start the race here. What the heck? That's not allowed.
Are you shopping?
Maybe that's
Nathaniel?
B still wins depending on how far you go.
Well, so that is the big question about. So careful saying B still wins because then you had to say depending on. But I do want to go with the B. Let's talk about B for a second. So this line, right, that goes up to B, but you can't see it because I kind of cut it off, goes to here and here. Nathaniel, can you help me with the slope of that line? 3 over 3, which is going to reduce out to what? 1. So really his speed is 1 what? Per what?
Per minute.
Guys,
That's a lot.
hold on.
That's a lot.
A kilometer every minute.
Bro, it's speedy.
Wait, is this
That's-
a bike race?
It is a
Yeah.
bike race. It's not a foot race.
Bicycle.
Guys, it's a bike race. Bikes can go really fast.
Red Bull really does give you wins.
Well, who knows? But
You win.
so now wait. So hold on. Nathaniel said depending on how long they go. So we just said B's the fastest. Why isn't B winning right now, Nathaniel?
Because somebody decided to cheat.
Well, okay, so A cheated, but what else is up with B?
They forgot to go.
Maybe B was in the bathroom.
They were
or
busy
somewhere
drinking
when the
Red
race started.
They're trying to finish the race.
Maybe he was still chugging his Red Bull. Right.
He was making sure he got them wins.
Guys, it's the tortoise and the hare. Right? Like, bicyclist B sat around for 5 minutes, shooting the breeze or whatever, and then finally was like, oh yeah, I should probably go. But then they're faster than Rider D, because after only 10 minutes of the race, they pass Rider D, and now Rider D is feeling bad about themselves. Then after another 5 minutes, they pass Rider C, and they're on the hunt. They're trying to catch up to Rider A.
And it's a constant
Yeah.
too.
So personally, I think that maybe Rider B, since they're so good going a kilometer a minute, maybe they got maybe it was
Maybe they got held back, right? Like, hey, you can't start with everything.
It was a handicap to
Yeah.
that it was fair for the other players.
Guys, so sometimes to level out the playing field, you'll have what's called a handicap. It either helps you out. It's like when you go golfing, it'll take some points off your score because that helps you. Or in other ways, you might get a head start, or you might get held back of hey, let them have a head start of a minute, then you can go. Hey, real quick before we move on from this, what's the slope of Rider D? What's his slope?
1 over 2.
Yeah, 1/2, right? Because it would be 2 compared to 4, or really half. So he's going half the speed as Rider B, right? Rider D is only going half the speed. Flip your paper over at a Ooh, wait, hold on. I'm trying to move on before I finish.
That's a lot of graphs.
Sorry. We said that this... Hey, flip back over real quick. We said this slope was 2/3.
Yep.
However, if we want to give the entire equation, can anyone help me with the equation for line A? All right, equations always start with y equals Alex.
Y equals 2/3 x plus 7.
Yeah, it's always your slope times x plus your
Which you start with.
y-intercept. Guys, be careful saying this is where we start. Not necessarily. What if this guy actually was just he needed to get to the finish line first, and he actually started before the race ever started? What if his line keeps going back here, and he actually started 10 minutes ahead of everybody else? This doesn't mean that's where he started. That is what we just call the y-intercept. Okay, break this habit of saying this is where we start. Yeah, it kind of looks like that, but what we call it is the y-intercept. So on the back, at a minimum find the slopes. What you would like to do to get all the way where you want to go, write out the equation for each line. So that'd be slope and y-intercept involved if we need to involve the y-intercept. All right, take a couple minutes. Slope at a minimum. Equation would be even better. Oh, and then whenever it's convenient, you could pull out your Chromebook and let it start loading up, just so we can get into Desmos more quickly here in like 10 minutes when we switch over to that. Make sure you're using lattice points to have nice points to find your slope from. What?
In Berkeley, we're going like this.
Well, yeah, because it's vibing. This music's vibing.
Did you overdo me, or do you just happen to say the same thing?
One of this dude's songs is legit called Vibin', but yeah, that's why that word's been stuck in my head.
Like over in Whisper to Berkeley, this music is vibing. Can't be a coincidence.
This very much reminds me of where we went for my sister-in-law's wedding, like down in Mexico, and I really want to go back because I didn't get to go on my trip that I'm sure I've complained about already.
What trip?
Over winter break, the trip I was supposed to go on,
Oh, yeah.
because thank you, Southwest Air.
Anytime. Oh, yep.
Wait, not an anytime thing.
All right, why? Who can help me out with 55-1 and explain to me why I just made like 6 different lattice points? Jacob?
Because it makes it easier to make the little triangle, because you know what...
Do I need all 6 of these?
You don't really need all 6 of them, but...
Definitely don't need them. However, they should all support the same finding. If I draw the biggest, from 11 down to, this is 10, and this is 5. What's 10 over 5 going to give me? 2. What would 6 over 3 give me?
2.
What would 2 over 1 give me? 2. Oh yeah, so no matter what size of slope, guys, what if I draw my triangle up here?
Still the same.
Oh yeah, it's still 4 over 2, so it's still the same. So our slope here is 2. Now wait, Lucas.
Excuse me, could I please have Olive Majors to the Perry office, please? Olive Majors to the Perry office.
So Lucas, can you help me build this into an equation?
So you would do y equals, so then you do 4 halves, or 2x.
Or just 2x, right? Because we don't have to make it more complicated than it is.
Plus 1.
Ah, because the y-intercept here is a 1. Any questions on how we get this equation? Mikey, what about our equation for... Actually, well, is... Guys, the y-intercept point is often a lattice point. So, Mikey, over here, can I use the y-intercept as a lattice point?
I guess you could, yeah.
Yeah, we can. Did you?
No.
Sure, what'd you use?
I used, starting at height of 3.
So, 2, 3. Really, you started with that point. Okay, what other point?
And I just used, yeah, 6.
So, like the next, wait, 6? You mean 4, 6.
Yeah, whatever.
Not whatever.
No.
X comma y is very important. Y comma x is very much not the same thing.
John said.
No, it's not whatever.
Yeah. He's smart.
So then if I draw my slope triangle, I have a delta y of 3, delta x of, so y equals 3 halves, careful, 1 and 1/2. Or you could just leave it as 3 halves. What's your y-intercept? Do I need this plus 0? Nope. You could just write y equals 3 halves x. Berkeley, what about part 3? Do you want to use the origin or are you going to use a different point? Sure, let's use the origin. It works. I'm going to go way out here just because. So that then gives me 6 over 9.
Yep.
What's 6/9 reduced to? Oh. Wait, aren't these the same numbers we just used?
What?
Who said no?
Wait, yeah, but they're just in different orders, right?
So, not the same slope. Guys, this is the trap door. X, comma, y matters as much as putting slope y over x. Right? Y over x. Y over x. If we goof this up, we're going to think, oh, they're the same. They're definitely not the same. This one is definitely steeper because this is y equals 2/3 x. Nathaniel? Oh, yeah. And then what about part 4? Caden went home, I'm guessing. Eli?
What? Oh, sorry. Okay, so I used the y-intercept,
We used the y-intercept. Okay, let me notate that.
and then I'm just gonna tell you your triangle. I went over 3 and up 2.
Up 3, over 3, up 2.
Yeah.
Sweet. So 2, 3.
Wait a
So
minute.
y equals 2,
Plus 4. So 2, 3, x.
2/3 x plus 4. There we go.
I did write that.
Wait, can I just infuriate everybody?
Sure, please do.
2/3 times x plus 4.
Thank you.
2/3 multiplied by.
Where'd it go?
All right, get your Chromebook out if it's not out yet. Get your Chromebook out.
I need to
Guys.
get a loaner. Is that okay?
56 is just reiterating. 56 is just reiterating. You can draw your triangles however you want. All of these would reduce out to the same thing. I already gave my loaner away. If you need one, you can either just work with your partner on the same computer or go find a loaner from another teacher. Yo. Marble slides. It should be the top one on your list. Should be. So, yes, some of us have done this already, but most of us did not get done with it. Actually, I don't know if any of us got done with all the challenges. After you work on Marble Slides lines for a few minutes, I will activate Marble Slides parabolas. But guys, there are a few things in Marble Slides lines that we gotta pay attention to. Like domain restrictions. We'll talk about what that means in a moment. Domain restrictions. There are domain restrictions. They are important.
She might not be doing
First try.
Oh yeah, and not on the first slide.
This should start to feel a lot easier than when we first. Guys, we first looked at this activity back in October,
You did?
and a lot of us were like, what the heck, how am I supposed to do this? And I was like, I don't know, just change some numbers. But now, the amount of growth that you've had from October to now, it's not like random guessing. You are using strategy. You are using your knowledge. You're using all your smarts to be efficient.
If you have too much fun, what smart? Yeah, what
If you have too much fun, you can reset it.
Yeah, he just read that. What smarts do you speak of, Mr. Hudson? Oh no, I remember this. Okay.
So any of our people playing along at home, I'm gonna turn off my recording because, music that isn't mine. But we're just gonna do marble slides lines for the rest of class. I will then also assign marble slides parabolas. So real quick, everyone look up front so we can talk about this super fast. In student, that's what I want to click on. In certain of these slides, you'll see this at the end of it. That is what we call, gentlemen, we listening? Because I'm not going to answer this question when you ask me exactly what I'm explaining right now. This is a domain restriction. I still feel like Alex isn't listening, but I'm just going to keep talking. This changes where the graph starts or stops, meaning if I make it 1, now my line starts at 1. If I make it 2, but it also depends on what direction this is traveling. So if I flip that direction around, now it's only values that are less than 2 versus values that are greater than 2, right? Like it is restricting where my line is allowed to exist. So if I change it to like 5 or 6, crap, not that, I deleted too much. Guys, those brackets are on your keyboard. Those exist on your keyboard. And if you can't find them, you can also click up the Desmos keyboard, right? You can click up the Desmos keyboard. But now my ball might be able to drop off how I want it to, or maybe I should make a second line. Guys, you don't have to only use the lines they give you. You can make more lines, right? You can add additional lines if you would like. Remember, Desmos is not just our activities, it's a playground. So if you come in here and you just click graphing calculator, guys, earlier Bryson was like getting all excited that he did x times x. And I was like, bro, that's exactly what I want you doing because x times x is what? And after a couple of seconds, you're like, oh yeah, x squared. This is a parabola. But then if you want to start playing with the parabola, what happens if I do x squared, then I don't know, like plus 4x? Or just plus 4? Or what happens if I, instead of squared, what happens if I make that cubed? And then what happens if I make that squared?
Stop it.
And remember, there is the Desmos art contest as well, if you want any inspiration or ways to do things. So when you look in here, everyone's graphs, guys, these are 13 and 14-year-olds, everyone's graphs have all of the different graphs. Guys, this doesn't need to make sense to you.
Too much math.
What this is a lot of copy pasting, and then they just adjust. Literally, you copy paste and change the numbers.
Could I please have
Which is
Mario
what?
Kart kids to the family room? All Mario Kart kids, head to the family room.
This is what we're practicing with these situations. What if I copy paste this and then start playing with it and adjusting it? What does it do? What changes? And you can copy paste if you want to. Right? You can copy paste if you want to be able to see the original and then keep playing with it. So, all right, keep going. I did not realize that I'm still recording, so I'm going to stop now because I started talking about stopping recording and kept going.